Welcome back to Manufacturing Unscripted. My guest this week is Jason Rolland from Carbon. Jason is an expert in 3D printing and walked me through Carbon's journey through 3D printing technology, specifically their use of stereolithography. We hope you enjoy.
This podcast is sponsored by Promus Incorporated, the leading provider of fully electric servo presses for manufacturing. Promus provides global support for pressing and motion control applications in multiple industries. With precise positioning and in-process force monitoring, your company will begin to see ROI on day one. Call 810-229-9334 or email sales@promusinc.com to speak with an expert engineer about your application today.
Welcome back to Manufacturing Unscripted. I'm your host, Peter Parsons, and today I am joined by Jason Rolland from Carbon. Nice to have you on the show, Jason.
Great to be here, Peter. Thank you.
So if you don't mind, would you be able to just introduce yourself? And one of the questions I always like to ask my guests is to just kind of give me the pathway to your career so far, so kind of the journey that you've taken to get to the position that you're at.
Yeah, sure. Happy to do that. So I'm Jason Rolland. I lead the materials team at Carbon. Carbon is a 3D printing company located in Silicon Valley in California. My journey there, I guess, started, with an interest in chemistry as an undergrad. So I did my undergraduate education at Virginia Tech and pursued a bachelor's degree in chemistry there. And along the way, really fell in love with organic chemistry and then later learned about polymer chemistry as a branch of organic chemistry and joined a research lab there and became really interested in all the different possibilities that and different products and markets that one could get into with a foundation of polymer science. Then decided to pursue a PhD. So I joined the DeSimone lab at UNC Chapel Hill in North Carolina. And Joe DeSimone was, a big presence there and had a really amazing research lab where people could pursue a lot of different projects and work. Really enjoyed my time there. It was awesome. Worked on a lot of different things, mostly in the sort of micro nano fabrication realm. But the other thing about Joe that I, didn't go in, expecting to embrace, but around the entrepreneurship. So he's the one who sort of introduced me to that, and really got excited about that the more I learned about it. And really viewed that as a way for the science that you're working on in an academic lab to branch out and actually impact the world. And your work doesn't just live in a journal forever. So really enjoyed that and had the opportunity with Joe to start a company. That company was called Liquidia Technologies. And they're still going strong down in North Carolina, and that was based on this micro molding technology and using it for drug delivery and other types of applications. So really, really enjoyed that kind of idea of taking your research project and then building a company out of it. So spent a number of years there, kind of building the company, scaling the technology, working on a variety of projects. I then joined another startup up in the Boston area focused on global health and stayed there for about 4 years. That was also a very cool technology focused on low-cost diagnostic devices. And then I kind of got a call from Joe DeSimone one day about this company Carbon, which was really early at the time. I think I came in as employee number 10 or something like that, and was tasked with building out the materials platform and the materials team for this new 3D printer. That was almost 12 years ago now. And so it's just been an amazing ride and just massive growth. And, we've really fulfilled a lot of the vision that we originally had for the company. Obviously, there's still a whole lot more work to do, but it's been a really wild ride. And so that's sort of the short version of how I got here.
Yeah, definitely. It's interesting to see kind of how the paths, kind of slowly twist around until they finally, meet you where you're at.
Yeah.
But definitely, I'd be interested to hear a little bit more about Carbon as a company, especially with you kind of coming into the company so early, kind of being able to see,
Yeah.
the kind of idealistic, this is what it was founded to do, and, being a part of making sure that that vision grows with the company.
Yeah, yeah, definitely. So the state of things, so this was about early 2014, and it was actually, interestingly enough, it was sort of the peak of the hype cycle for 3D printing, and there was a lot of inflated stocks and a lot of ambitious vision for what 3D printing could become. People were talking about everyone's going to have a 3D printer in their house, and if you need a new toothbrush, you just go down in the basement and print your new toothbrush and things like that. And so it was an exciting time for the industry. At the time, we had a really interesting new printing technology that we called clip. And the story there was, I can get into the science if you're interested, but the story there was basically it was a faster 3D printer. And there's a lot of different types of 3D printing, but one segment is in this area called stereolithography, which is based on light patterning of materials with light curable materials. And the original innovation was around the interface between the object being built and the resin cassette. And how do and there was innovation there to make that print 10 to 100 times faster than previous 3D printers. And so that was really exciting. And that was the initial spark of the idea of, hey, what if we took 3D printing in a really different direction and made it an actual manufacturing technology rather than just a prototyping technology, which was most of the use case at the time was all around prototyping. And so if you want to do that, then the first thing you do need is a higher throughput printer that can print fast. And so we had that. Then there was a whole lot of other work to do, but another big piece of what you need if you want to go into production is you need materials innovations that allow you to make end use products that have all the properties you need for something like a running shoe or football helmet cushioning or automotive parts and et cetera, et cetera. So there was a pretty big task on how to do that because typically UV curable polymers are used in coatings and things like that. They're not typically used to make highly durable 3D parts. And so that was what we had in front of us. We took a very unusual and different approach to the chemistry that paid off in a lot of ways. I can get into that if you're interested, but that was sort of the second big breakthrough was we were able to really level up the performance of the properties that you could get out of this printer. And then because, we were in Silicon Valley and, there's a very, software-oriented mindset here. We recruited an engineering leader, Craig Carlson, who sort of brought this idea of connected devices and modern software architecture to the platform. And that was sort of the third leg of the stool, if you will, of what allowed us to build Carbon. And since then, we've innovated on all of those things on the hardware, on the material side, and on the software side, and continue to, really push and create great partnerships with big brands and with contract manufacturers who actually have built factories full of our printers, and really just made a ton of progress in that original vision of taking 3D printing and making end-use products with better performance than the standard products. So yeah, that's again a short version of the Carbon story.
Yeah. So one thing, I know a lot of people, they might be kind of more familiar with 3D printing kind of more from a hobbyist perspective, rather than kind of the additive manufacturing industry.
Yeah.
But at least kind of from a basic level, you're putting layers of material, whether that's being extruded or through lithography. But I know with a lot of things, there's usually the biggest trade-off of speed and quality, where, the faster you go, the less accurate you might be, whereas, the slower you are, the more precise you can have your details or your part necessarily be. Mm-hmm. So what does it take to kind of overcome that gap of being able to speed up the process while maintaining resolution?
Yeah, really great question. Yeah, the short answer is it takes a really awesome engineering team, and sort of everyone working together. But yeah, one of my favorite things about Carbon is it really is a truly multidisciplinary company in that, our technical team, has material scientists, chemical engineers, we have software engineers, and we have mechanical and electrical engineers, and everyone has to work together. And it's not a place where people can just kind of do their part and then sit back and say, well, hey, I made the resin, you guys figure out how to make it print. That doesn't work. And so we've always had this emphasis on the most important thing is the part that comes out of the printer. And that is a combination of a lot of people's work, to get that to your point, to come out accurately. Yeah, I guess the more technical answer is it's one of the reasons why we gravitated to the light curable printing technologies, because those tend to be much more accurate, and they have these modern, what we call a light engine, which is just a digital projection of pixelated light. And you're able to take advantage of modern optical systems and get down to pixel sizes that are, anywhere from 70 microns to 150 microns. So just to orient people, a human hair is about 100 microns. And so you're able to get to really precise detail around the light patterning. And that's sort of the starting point of your accuracy. And that puts you already in a better starting place than if you're doing some of the extrusion systems or the powder-based systems where your resolution is ultimately limited to the, size of your particle granules. So I think the light-based approach is, set us off to a good start. But to answer your question, I mean, we had an entire team, have an entire team, called the print development team, and their job was to sort of sit at this interface of the hardware and the materials and the software, and create these print algorithms that can compensate for a lot of variability, whether that's printer variability or resin variability, even temperature fluctuations. There's a ton of work on that, and so it really was just a gigantic engineering project to take all the stack of contributors to the variability um, and knock those down either through software algorithms that can correct for it, or from, just, really hammering in on our supply chain for resins, for example, to make sure we're making the most consistent products that we can, or really hammering on the hardware side to make sure that the light engines are as consistent as they can be. And so it's sort of this big stack up that ultimately leads to a good place there.
Yeah. So would you say that Carbon kind of really leans into just like specifically resin printing, or is it kind of more so you have multiple different material types that you work with, but maybe some you kind of excel more, or maybe I guess one way you could word it is kind of your signature is using
Yeah.
like the resin?
Yeah, so we're strictly polymer based right now, and so that and in that category, we are strictly liquid resin based printers. Now, within that category, we have a huge variety of materials now that have lots of different properties. I would say a specialty of ours has been around polyurethanes. And we had a really big breakthrough early on how to make exceptionally well high performing polyurethanes, because we were talking to footwear companies and looking at making midsoles for running sneakers. And, again, it's not enough to have something that's sort of, oh, it's rubber like, no, this has to actually perform on par with a polyurethane foam, which is what we were competing with. So we got really, really good at making high performance polyurethane products with both very high energy return. We also have products that have very high energy absorption, so that are more like a memory foam type of thing. We use those in our football helmet products. And then recently, we've gotten really interested in foams. So we're able to actually print materials that during a baking step are able to foam. And so now we have this sort of cool combination of 3D printing and polyurethane foams that allow us to get into new and exciting applications. Outside of that, we also have done a lot in high temperature materials. That's been an emphasis. So a lot of epoxy-based chemistry lends itself really nicely to our platform. And we've been able to make, again, really high performing materials that kind of solve this combination of heat resistance, impact strength, functional durability, and accuracy within the printer. And so those are used for lots of enclosures and electrical connectors. And we have parts that pass all the requirements for interior automotive. So it really just spans the gap. But yeah, we're within that space. We've been able to do a whole lot in terms of the range of materials.
Yeah, I'm kind of curious. One thing you had mentioned was kind of mixing the two different types of filaments, where you have that kind of a standard structure, and then you have a foam structure that's being mixed in with it. Is that kind of a way to kind of fill up the internal structure while needing less materials, or?
No, it's a bit different than yeah. So first of all, just to clarify, we don't do filament-based printing. So that's a whole different category called FDM. And so there you have like a spool of thermoplastic, so something like nylon, and it's going through a nozzle that then is heating it and then basically drawing the part line by line. I think that's a very useful category of 3D printing. It's just not a space that we play in. What we work in are these liquid UV curable materials. We've taken a bit of a different approach where we have both UV curable and thermally curable chemistry kind of all blended together. So that's sort of the starting point. And so within the polyurethane space, the way we got to the foams is we take those liquid resins and we add in these little particles that will actually expand when heated. And so you have imagine this liquid resin that has these particles dispersed in it, but it's not yet foamed. And so you print your initial part, whatever it is. Usually it's some type of lattice structure for us. That comes out of the printer. It's then the residual resin is removed. We have a number of ways that we do that. And then the part is placed into an oven. And so the baking step serves two purposes. One, it activates that secondary thermal chemistry, which allows us to get to these really great properties. But in the case of the foaming agents, it now also activates this expanding particle. And so you sort of get this uniform volumetric expansion of the part in the oven after printing. So that's how we're able to do that.
Okay. And what would the benefit of having a foamed part be rather than just a standard printing of something of that size?
Yeah, it's a great question. There are performance benefits, so you can get to even lighter parts. The lattice structures are interesting generally because they have a really nice strength to weight ratio. That's why you see them in building construction and bridges and things like that. The foaming takes that a step further, where now I have something that is a significant percentage of air after that baking step. So you have lightweighting. It also has this neat benefit of being able to print parts that are actually larger than the build area of the printer. So you can print something that's fairly big, put it in the oven, and it gets even bigger. And that's useful for a lot of applications in seating and things like that we're looking at. And then you have other benefits, that matter, things like surface texture and that sort of nice silky surface feel, that matters in a lot of applications. A lot of people just pick that up and they go, "Oh, wow, this feels really good," and I want this in my product or in my shoe, for example.
Yeah. And I think one interesting thing I like to think of too is kind of the way that innovations are found. And in some cases, it's innovation kind of brought out because there's a specific task that's being looked to have been found.
Yeah.
Whereas other times it's more so, using the developments in innovation to find use cases. So I guess for carbon, what would you say is kind of more common is developing a solution for a specific task, or kind of more so finding a solution and then trying to find a task it would be applicable in?
Yeah, it's a great question. I like to think of that as sort of you have these internal developments that you then say, "That's really cool. What can I use this for?" And then you have things where it's like, "Hey, I talked to customer XYZ, and if we can do this, then, they are willing to, make X million of parts or something like that. And I would say we have a fair amount of both happening. The foaming example, actually came out of a sort of exploratory effort. I have on my team, we have a certain amount of time where people can just go in the lab and play around and try things and, just allow that freedom. And it sort of came out of one of those types of efforts where it's like, hey, I came across these foaming additives. This would be interesting. And so actually we kind of sat on it for a few years and just sort of knew that we had this capability and we're just waiting for the right thing to apply it to. And a lot of times it's just a matter of timing with the right customer, with the right opportunity and that kind of thing. But we also do a fair amount of the other way where, a good example would be our partnership with Adidas early on. We first met them in 2016, I think. And, they were excited. They saw some of our initial elastomer materials and recognized that they were quite different from anything they had seen in 3D printing before. But they gave us a spec sheet of like, well, we want to move forward. We want to do significant volume with this, but here's what it has to do, and here are the tests it has to pass. And so, we have a team of people working very hard on developing materials that meet all of those things. So, yeah, I like to think of it as, there's a fair amount of both happening, and I think both are really important because if you don't have that freedom to just try cool things, then you're always just in responsive mode to what the latest conversation. Whereas, you'd like to think that you can have room to explore things that may or may not be useful, but, you at least have that freedom to try it.
Yeah, definitely having that ability to kind of develop a solution and maybe it doesn't pay out or maybe it doesn't go anywhere, but you still have that level of knowledge, not only of, this isn't a viable solution, but now it's, just more experience and more time just put into that developing mindset.
Yeah, and you might put it on a shelf for a bit and lo and behold, a couple of years later, someone comes in and they need exactly that thing. And you've already done the proof of concept to know that it's possible.
Is that fairly common for you kind of at this point now that there's been a lot more established business, there's been a lot more established solutions? Is it kind of more common for someone to come in just looking for what's already been done? Or do you still get a good mix of people coming with kind of new challenges?
We try hard to keep the sales and the business development teams focused on selling our existing products. But they're also the first ones to kind of hear about from a customer, well, hey, this is great, but if you had, this kind of material, then I could do even more business. And so they are really important in terms of sort of like scouts going out and looking for new opportunities and then feeding that back into the R&D teams of saying like, hey, we could double our business in this segment if we had something that did, the XYZ or something that was a bit different. So, yeah, I would say we're doing a pretty good job of being able to manage internal innovation. It's funny the way things work. I think there's actually years where we sort of have heavy innovation and we're innovating and trying new things and developing new materials. And then you have years where it's all hands on deck to just sort of really commercialize those products and make them very robust and do all the really hard work to make it a reliable, repeatable product. It's sort of the R and the D side of research and development, and they sort of go in waves. And so, I'd say actually this year we've sort of had a very heavy kind of capital D, year where we're just really refining this new product for a really exciting application. And then we hand that off to our chemical suppliers and they can just manufacture that. And then the R&D team's time is freed up to then go back and, innovate and develop new things. And it's sort of a cyclical type of thing.
Yeah. One thing I'm wondering if you can maybe clarify a little bit, because I'm still kind of trying to put my finger on it. But as a company, are you providing the solution to develop a certain product, or are you providing the printers? Are you providing the service of developing the parts? I guess, would you be able to kind of clarify what your role is?
It's a really great question. And so We have a subscription model for the printers, and that was another kind of innovation on the business side that we did, which I'm happy to get into. But so customers can subscribe to printers. They also purchase resins from us, so we have a substantial resin business. The software is included as part of the subscription, and the software also gets better over time. And so, just like a lot of devices now, you get software updates on the printer that make it work better, and have improvements. So that's sort of like the base offering. But what you're hitting on is really important because we went through a pretty big shift in our business model about 3 years ago, where in a lot of segments, we were basically just trying to do a more traditional sales model, which is to go find companies, place printers there, and then let the customers print whatever they wanted, and that was our business. What we started to realize was that with the goal of moving things into manufacturing and into production, it required a lot more work and collaboration between Carbon and the customer to really fine-tune that product, to get it to print correctly, to get it to perform correctly. There was a bunch of design work, designing the lattice structures. It's not something a lot of people are familiar with or know how to do. And so we started to realize that, in the consumer products space in particular, that model of just sort of, selling printers or subscribing printers and dropping them off, it wasn't working. And people were struggling to sort of, take this system and make products from it. And so we started to shift from a model of printer sales to a model of application development. And so we kind of restructured the team and we built a substantial applications engineering team. And that team's job, and so now we're going to, a company like Adidas or Riddell or Specialized, and instead of saying, "Hey, you should buy a printer, it's really great," we're saying, "What products do you want to make?" And it's actually a much easier conversation because it's less of a sales pitch, and they don't feel this pressure to buy something. It's more of a collaboration of, how can we design the best performing football helmet that's ever existed? And okay, well, yeah, I'm interested in that. That sounds great. And so then we work together to do that. And then the idea is that, so Carbon still has to make money. So then the idea is that once you have developed that product and you have volume secured of that product, you can then transfer those jobs to your contract manufacturers, again, these factories that are filled with our printers. And they're the ones who are going to buy more printers and buy more resin. And so it's just this big shift in sort of the approach of how do we get this technology out in the world making products. And it's really paid off, where we've started to really see an acceleration of the number of products and the types of products that are bringing in and that our system is able to produce. So yeah, it's a great question because it was a big shift in our business model.
Yeah, and definitely, I imagine that's got to be a big learning process just to, shift the entire business model and just kind of change the way that you're offering services to customers as well as the way that customers are interacting with the product.
Yeah, and then we also have a fairly sizable business in oral health and the dental industry. And there, the more traditional sales model does work quite well. And that's because you have thousands of these dental labs across the country, and they are expert 3D printing users, and so they don't need the help that some of the other products that are very new to the world need. They just want a printer that's reliable, that prints well, and has a bunch of great materials, and they can go off and print dental models and dentures and night guards and these types of things. So. It's complicated. So in certain segments, we do follow more of a traditional sales model, and in others, we're very, very focused on application development and that pathway.
Yeah, and not to go off on too much of a tangent here, but I imagine with anything dental related or medical related, I imagine that comes with its own set of kind of challenges and restrictions just to make sure things are completely compliant, especially if they're going to be, put in people's mouths or installed 100%. In their body.
Yeah, and so you do have like the resins are FDA regulated, for example, in dentures and night guards and things like that. So you do have pretty strict regulatory requirements there.
And is that something that you mentioned most of these labs, they're already people that are, well qualified experts in kind of this specific area. So is that anything that you really need to get involved with? You had mentioned like a software that you use with the printers.
Yeah, so we have software products that we develop, and we have developed software tools and products specifically for that market segment. So, one example would be we have this software product that basically automates the process of having, these labs will print thousands and thousands of dental models. So when you go to the dentist, and it used to be they put the goop in your mouth and you'd have that really uncomfortable experience. And then they take that and they make a model of your teeth out of that. Basically, they can get a negative and then they pour, other material into it and make a positive. And then the dentist will use that model to make sure your crown or your bridge fits before they put it in your mouth. And so there's a sizable volume of parts that are printed in that industry that are just models. And so we developed software tools that basically automate the sorting of all of those models, arranging them into a print build, and sending it off to the printer rather than having somebody sit there all day and move models and orient them on a build. So we do things like that are specific, industry specific, to benefit those customers.
Okay, yeah. And I'm wondering if are there any other industries kind of maybe similar to medical that kind of come with their own challenges or restrictions? I know you'd mentioned a lot of like footwear, like Adidas and things like that. Are there any industries that maybe people might not realize make use of like additive manufacturing?
I think, yeah, I think a lot of what we're doing in the consumer product space is getting more and more well known, but probably not as well known as we would like. And so, our partnership with Adidas has been pretty public, and that's been really exciting. Things within football helmets are really getting exciting. The NFL puts out an independent ranking of the performance of football helmets every year with respect to safety and ability to absorb impacts and things like that. And what's been really great is the last 6 years a helmet containing carbon technology has been at the top of that list, and usually we're sort of half of the top 10. So that's been really exciting to see, and I think most people don't know that. The other fact is I think it's around 70% of NFL players are wearing helmets now made with our technology. And our partners are now taking that and expanding it into college, high school, and even Pee Wee football, so that everybody can have access to this, the best protection. So that's probably something that I think a lot of people don't yet know about that they should, because again, it's not enough to just say, hey, look, I 3D printed this. Isn't that cool? It has to provide some benefit, because oftentimes it's a bit more expensive than the foam padding used in a football helmet, for example. And so within helmets, you get a much higher impact absorption with the combination of the lattice structures and the materials. And it's also something we invested a huge amount of time in. And you also get a lot of breathability benefits, as you can imagine. If you have, foam all around your head versus an open lattice structure, it's much more comfortable to have the lattice structure. So that's a big area for us. Bike saddles are another really rapidly growing segment for us. We work with all of the top brands. My favorite stat in that segment is in the Tour de France this year. 6 of the top 10 riders were riding on saddles made with carbon technology, which is really cool, including the winner. And so, we have just a lot of these proof points like that out there to say, like, hey, 3D printing matters. It can make products better, and it can make really high performing, end use products. And we're continuing to expand in a lot of other areas as well.
Yeah, and it's really interesting just to see the kind of real-time expansion and just how much, this technology is really able to be used in pretty much any industry, in pretty much any products.
Right.
And I'm wondering, just kind of with your experience, just maybe the history of that kind of printing, like kind of where was it 10, 20 years ago? And then maybe kind of in the inverse, one thing I always just like to think about is, what's the next step? What's the expansion? So maybe what's kind of around the corner, or what's the innovation that we're still searching for?
Yeah, that's a great question. So looking backwards, I think, the 3D printing isn't new. It goes back to the early 80s, I think, maybe even before that. And again, the initial technologies were, I believe, stereolithography was first, which was just sort of these vats of UV curable resin, and you sort of write with lasers on top, and then just keep lowering a platform as you cure these parts. And it was even, marketed under this phrase rapid prototyping. And so and there's it's nothing against that. That's actually incredibly important. And you need tools that you can use to prototype parts before you go and manufacture them. And then there were other technologies around the powder systems and the filament systems, and each of which, have their pros and cons. I think that carbon in particular has started to lead the way of applications and end use products, and trying to expand this industry beyond just simple prototyping, or tooling is another popular use for 3D printing, to sort of, you can print your injection molding tooling and that kind of thing. So I think that's sort of the current state, is that there is a lot of meaningful proof points that that you can use additive manufacturing for these end use products. Looking forward, I think there's one of the things I love about it is there's just endless possibilities. I think that, if I really kind of push the limit, I think there's still so much work to do in the medical sector. I think one of the things that 3D printing is particularly good at is making customized parts. And you think about like the dental model example, every single part you're printing is different, and it's custom to that person's mouth and that person's teeth. And the same would be true of dentures or any other dental product. But that's just, one part of your body. And, everybody ultimately is going to have a better outcome with a customized medical device specific to their problem, or or that particular part of their body. And so I think this whole idea of under the phrase mass customization is the future. That why should we have all the same earbuds, and why don't we all have customized earbuds that are contoured perfectly for our ear? Why don't we all have custom bike saddles that are contoured for our body? Why don't we all have custom football helmets and all these types of things? And that's just sort of these surface level things. But then you get into stents and, just all sorts of much higher risk but higher value medical devices. As a step towards that, another area that we're looking at and very excited about is in wheelchair cushions. This is an area where there hasn't been much innovation in a really long time. And now you have these lattice structures that provide much better support than foam. They can be customized both for pressure points as well as for contours, and what shape people need to be comfortable. You're spending all of your life in this chair in many cases, and you want that person to be as comfortable and safe as possible. You have this huge problem with sores, and these can be very painful and lead to weeks of recovery in the hospital. And that's all around managing pressure, moisture, and heat. And those are all things that we can do very, very well in a lattice structure when compared to a foam. So we're really, really, really excited about that. You can read more about that on our website. But I think that's a super exciting area for us in the medical realm. And I think there's just so much more to do, both in consumer products and medical and everything else.
Yeah. One other area I'm curious to maybe get a little bit information from you on is just in terms of kind of environmental impact and like sustainability. Especially when you're looking at, these mass productions where you're producing things like sneakers, things like medical implements, anything like that. Just in terms of how this kind of newer material and these newer innovations in this assembly technology, how does that differ from kind of like multi-mass use plastics and things like that?
Yeah, it's a really great question, and it's not It's nuanced, right? So it's pretty complicated, and it depends on what you're comparing to, and a lot of factors. But I can talk about some of the things that we have done. This is an important topic for us, and something that we do think about quite a bit. The first thing I would point to is in resin-based 3D printing, one of the sort of dirty secrets of the industry is that you have just a lot of waste to deal with, that your part comes out of the printer and it's dripping with resin. And so the standard way of cleaning that is you take the part off and you dunk it in a solvent like isopropyl alcohol or, acetone or things like that. And then you go and you have your part, but now you have this solvent with resin dissolved in it, and that has to be disposed of as hazardous waste. And so that's not only environmentally unfriendly, but it's also economically unfriendly because it costs a lot of money to dispose of hazardous waste. And so we early on pioneered a cleaning technology that used no solvent, and it's all just based on centrifugal force. And so you basically spin the part and all the residual resin flies off. It can then be recollected and poured back into the printer for the next run. And so there you have at scale, you're running a really low waste process compared to anything washed in solvent. So that's sort of the initial breakthrough that we had, was how can we make this more of a dry and less wasteful process? And also, again, there's economic savings there too, because we want to get to price points that are competitive with, standard materials. Second thing that we've done on the material side is invested a fair amount in bio-based materials. And that's more of a carbon footprint story. A lot of people hear bio-based and they think, oh, great, that's compostable, right? But no, it's just bio-derived, meaning you're making the building blocks of the polymers from sugars and other types of plant-based products. But we've been able to make resins that have, 40% bio content and therefore a lower carbon footprint used when manufacturing the resin. You can also get into arguments around energy usage. And again, that's a complicated topic, and it highly depends on the part and the resin that you're using and the type of workflow that you have. But we've done some analysis where it does look like you can get better energy usage and therefore better carbon footprint in certain conditions with additive manufacturing. And again, you have to think of the bigger picture of injection molding pellets being made in Asia and then being put on a, cargo ship that then travels around the world to a factory, and then the parts travel, wherever they're going. And so you have this idea of centralized production that's possible with additive manufacturing, where you can have, small to medium-sized factories that are located in, geographically closer to where the end products are being assembled, for example. And so there's a lot of studies you can read about in the literature about, where additive manufacturing is quite favorable actually compared to processes like injection molding in terms of energy usage. Again, not in every case, but in certain cases it's true, especially at, low to medium production runs and things like that. Then the final area that we get asked about a lot is recycling. And we could do another hour or two on recycling. Recycling generally is not in a great place worldwide. The numbers are pretty bad in terms of even the products that can be recycled in terms of their success rate. But within our world, we looked at that and said, well, one thing we could do is to try to make sure that the parts that we make can be melt processed and molded into different parts and different things in the same way that the more traditional thermoplastics can be reused. And we are able to do that with our polyurethane elastomer chemistry. We're actually able to make, through the unique approach that we've taken to the chemistry, we can actually make parts that are melt processable at the end of their life. And we've done demonstrations of that, and we've shown that, you lose maybe 10 to 20% of the mechanical properties. That's pretty typical. But we do have a system that could fit into a recycling workflow. But that's just one part of the equation. You ultimately need brands and, to create these ecosystems where people send their shoes back when they're done with them and they're taken apart and recycled. And that's a much bigger problem. And we're only, one piece of the puzzle there. So yeah, it's a really big topic. And I think there's certainly always more to do there, but it is something that we've focused on in a fair amount of areas.
Yeah. And it is one of the kind of unfortunate realities that a lot of times environmentalism is kind of a luxury of larger scale manufacturing.
That's
Where
right.
a lot of, mid to smaller size manufacturers don't really have the ability to kind of have that as a decision maker, just because a lot of times of how close the costs need to be
Yeah.
just to keep lights on, just to keep product moving.
That's right. It's also a world where people tend to want perfection over iterative improvement. And I'm a believer that if you can take steps, to move in the right direction, that matters and that counts. And, it shouldn't be this case where either you make it perfect or you do nothing. I think these sort of iterative steps are important.
Yeah. And one level on that, maybe along the same train of thought, but in the sense of kind of comparing different companies and the way they go about their business, different things like that, is there kind of an ideal type of customer for Carbon? And then maybe on the inverse, is there a type of customer where you might say to them, we're not a good fit for you, or, don't come to us for that kind of solution?
Sure. Yeah. Ideal customer, again, with the markets the breadth of markets that we cover, I would say typically the ideal customer for us is, a designer or an innovator or a maker who is always seeking to improve their product, or a brand that's like maybe they're the number two brand and they want to be the number one brand and they're looking for an edge. And they're looking for a competitive technology that allows them to beat their competitors. Those are where we've had the best luck. And again, someone who's willing to put out a product that might cost a little bit more, but has higher performance. I would say those are sort of one category of ideal customers for us. I think dental labs generally are ideal customers for us. We just have an amazing product there. We do great with all the, independent surveys on best technology in that space. So that's another segment. But again, a very innovative segment on its own that is pretty ahead of others in thinking about how to use this technology. To answer your other question, yeah, there's tons of things where I wouldn't recommend you use our technology or any 3D printing for that matter. My favorite example I usually give at talks is usually a bottle of water nearby. Like plastic bottles of water, it's never going to make sense to 3D print something like that. Those are made insanely cheap and very efficiently by blow molding. And there's a lot of injection molded products that will just make sense to keep injection molding. Where we specialize is in these high performance products and these types of geometries or customization, or maybe you only need to make 10,000 of something and you don't want to go and cut tooling for that. Those are the types of things where I think we really shine.
Yeah. So maybe one kind of final question I have for you, but one of the things that you said right at the beginning kind of struck me, where you were talking about kind of the explosion of 3D printing technology. And, when there was a lot of hype around it, a lot of people were, thinking, how far can this go?
Yeah.
And I know currently we're experiencing a little bit of a similar boom with, artificial intelligence,
Oh, yeah.
AI, everything like that.
100x.
Yeah. So I'm just kind of wondering, are there any maybe parallels that you can see kind of between these two, where I know, like you mentioned with 3D printing, at one point there was the idea, have one in your house and print anything you need, print silverware, print plates.
Yeah.
And I wonder, from that large explosion, there was, so much optimism, so much, so many ideas, and then it kind of slowly boils down into, this is what makes the most sense. This is what's feasible. I'm wondering, just kind of from your perspective, if, with the AI explosion and everything in that same sector, are there bits of that where there's things that you might be optimistic about what you can incorporate it into, your company and your work processes?
For AI specifically?
Yeah.
Yeah, it's certainly not my area of expertise, but I guess the first thing I would say is there's so many examples of products that go on this hype cycle curve where you just have the initial breakthrough and then the expectations immediately are insanely high. And then when the product can't live up to those expectations, it comes crashing down. And then you have the long, slow build up into reality and actually making it. And almost every breakthrough innovation follows that type of hype curve. And I definitely think we're at the peak with AI right now, where the expectations are just insanely high. But I do think there's a ton of utility in what's coming, and there are companies focused specifically on that. Just to name a couple, I think there are several companies in my world on the material science side who are working to build, formulation tools that help, are sort of like assistants to a material scientist in navigating the maze of raw materials and different reagents and different things I can use. I always use the analogy of a Rubik's Cube in materials development because you can't just solve for one property. You're trying to solve for, I don't know, usually 8 to 10 different properties that the material has to perform, all of them. And many of them are trade-offs, so like stiffness of a resin with the toughness, for example, is a pretty significant trade-off. So I think that there's a lot of room where you could imagine the AI tools that help shortcut that process that my scientists go through of just crunching through formulations to get to that right answer. That's one big area. I think on the part design side, there's a lot of exciting things happening where and there's already companies doing this where you can just sort of type in a description of the part that you want and it spits out a CAD file would be the dream. I think there's a lot of room there. I think, lattice structures, we have our own software tool called Design Engine that can take a certain set of inputs around cushioning profiles and things like that, and it will spit out a lattice geometry that meets that. I think there's a long road of cool things you can do towards that. And then ultimately, I think you can imagine, so-called lights out factories that are just fully automated, filled with printers and, robots kind of taking parts out of printers and going through all the post-processing, and there's a huge movement towards that type of factory. And I think we're primed to fit right into that. So yeah, I think there's tons of areas of overlap.
All right. Well, Jason, thank you for talking with me here today. It's been an absolute pleasure. I've definitely learned a lot. Hopefully the audience has as well. Before we close out here, I know you had mentioned that your website has a lot of resources and a lot more information kind of on this specific technology.
Yep.
Is there any other maybe resources or anything like that you might want to shout out or make people aware of?
You can look at our social media pages on LinkedIn and Instagram. I think we have a TikTok page now that's pretty fun. But I think the website probably has all of the information that someone would be interested in. So I definitely encourage people to go to carbon3d.com. All
right. Well, Jason, once again, thank you for joining me here today. And I'd also like to thank our audience out there for tuning in week after week. Feel free to subscribe wherever you get your podcasts. And until next time, we'll see you then.
Thanks, Peter.
This podcast is brought to you by Promise Incorporated, hosted by Peter Parsons, produced by Lauren Rawl, and mixed and edited by Ben Parsons. If you have any questions or would like to appear on the podcast, please reach out to podcast@promiseinc.com. Thanks for listening.